Hello and welcome to the video. This video is about a thinking routine known as principle, since, therefore, or PST for short. It is a thinking routine that is directed towards explain questions. If you were to take a look at your 10-year series and browse around the questions there, you'll notice that explain questions tends to show up with some regularity. If you were to total them up across the paper, you would notice that they take up approximately 20% of the written questions inside paper 2 and paper 3. Because they take up about 20% of marks, it would be very useful if we have a thinking routine that allows us to structure our questions well and even help us if we were not able to think of an answer because the question might simply be too unfamiliar or too complex for us to work very quickly through. In addition to explain questions, sometimes you might encounter suggest and comment questions. And these question types would also benefit from the PST routine. Before we get into the routine, let's first establish what is an explanation. According to the Merriam-Webster dictionary, an explanation is the act or process of telling, showing, or being the reason for or cause of something. According to the Britannica, in philosophy, an explanation is a set of statements that makes intelligible the existence or occurrence of an object, event, or state of affairs. That being said, what is needed in an explanation? One of the structures of an explanation is known as the covering law model of explanation, which I will be making reference to. The covering law model comprises of 3 statements. The first statement is a principle. If X occurs, then Y will occur. The second statement is a since statement, which sounds like since X has occurred. And then the third statement is a therefore statement, something like therefore Y will occur. So you can see how these 3 statements tie together. The principle relates X to Y. If X were to occur, then Y will occur. Or conversely, if X does not occur, then Y will not occur. And then the since and therefore statements establish whether or not X has occurred, and then logically, Y must or must not occur. This is known as the PST routine. Let's have a simple example. Say one day you have made a sandwich. You're really excited and you want to pair it with a drink. You head to the refrigerator to pick up your drink, and when you come back, you see an empty plate with crumbs because your sandwich has been eaten by your friend who is standing next to it looking very satisfied. And of course, you ask the inevitable question, explain why you ate my sandwich. So you tasked him to create an explanation for you. So how would he reply to you? The question is, explain why you ate my sandwich. And this is his suitable response. He says, principle, if people are hungry, they will eat. And you can see the if X, then Y structure. Since I was hungry, therefore I ate your sandwich. So of course you'd still be rather upset, but logically what he said was sound. The PST routine helped him to come up with a good explanation as to why he ate your sandwich. So let's break it down and examine the meaning of each part. The principle. So the principle is a relationship between 2 or more variables that is applicable to all relevant contexts. You learn a lot of principles in physics. Take, for instance, Newton's laws of motion. For example, Newton's second law of motion connects the forces an object experiences to its eventual acceleration. We have the principle of conservation of energy and the laws of thermodynamics. And every single chapter you're going to learn has 2 or 3, maybe even 4 principles that you have to learn. On the other hand, the since and therefore statements are not general principles that connect the variables. Rather, they are contextual statements regarding the problem at hand. So we take our principles, and then we go and look at actual systems in the world. For example, we might be looking at a car slowing down, and those statements would be our since and therefore statement. The wave's amplitude decreases, the gas temperature increases. You can see the very contextual nature of these statements, looking at the problem at hand. Let's have a simple example of an explanation in physics. Take, for instance, a ball being dropped from rest. Explain why it accelerates. The response? Principle. Newton's second law of motion. If an object experiences a net external force, it will accelerate. Since the weight of the ball provides a net force, therefore the ball accelerates. Once again, the principle is a rather overarching statement for all relevant contexts. You can see there's nothing really much contextual about it, but it's simply if an object experiences an external force, it accelerates. And then the since and therefore statements pay close attention to the ball. Let's look at another common example of an explanation in physics, and this is something that's a little bit more typical to what you'd see in the examination. Take a look at that circuit over there with EMF, a resistor, and a bulb. The EMF of a battery is increased. Explain how the brightness of the bulb changes. And then you have 2 marks here. Now, typically, if we see a 2-mark question, we are going to require 2 sets of PST. I'll demonstrate. So the response we have here is the principle I equals to EMF over R. You might find this rather familiar. Since E has increased, which is the EMF of the dry cell, therefore the current in the circuit increases. Now, I hope you can see that I'm not really writing this out in full sentences. Rather, this is a thinking routine that's meant to support you in eventually writing the full prose response. All right, but I'm trying to keep it simple here. I'm trying to keep it fast because it should be a rather fast thinking routine to help you in the exam. Now let me continue. So at this juncture, I've noted that the current increases, but this speaks nothing of the brightness of the bulb. So I carry on and I introduce a second principle. Power equals to I squared R. And why I bring power into the explanation is because brightness is more or less an energy expression, right? It's the amount of light energy that's coming off the bulb. So I make reference to power. So power equals to I squared R. And since the current through the bulb increased, therefore the power of the bulb, the power dissipated by the bulb increases and brightness increases. So yes, it's written in shorthand. It's not great in terms of grammar and the expression of writing, but I hope you can see the thinking routine that's going on here by using principles and connecting since and therefore statements. There are other features of this explanation that I would also like to share. Now, what I'd like you to see is that there are 2 sets of PST, and the first therefore becomes the second since. What this does is that it's establishing a kind of causal chain where I make one deduction, and then that deduction is applied into the second deduction, and hopefully I can do this quickly and achieve the final mark. All right. So 2 marks generally requires 2 sets of PST. It's just a rule of thumb. Sometimes that varies, but sometimes I can also see 3 marks, 4 marks, 5 marks, and then of course the explanations get longer and longer. But very typically we see 2-mark explanations that require 2 sets of PST to get to the end logically. Now, how would this explanation be marked, which is of course a concern that we all have? Well, to be upfront with you, principles generally, not always, generally are not marked. Because most of the time you would get marks from principles when you recall them. But nonetheless, I hope I've impressed upon you how important they are to reach your explanation conclusions. So principles generally are not marked. And then the first since is also not marked in this case because you are simply repeating the question. The question already told you that EMF of the battery increases, so you generally get no marks for repeating that fact. And then, like I said, the first therefore became the second since. So there's a repetition of that statement there. So the second statement probably will not be marked either. That leaves us with 2 marks. Therefore, current increases and the power of the bulb increases, brightness increases. And I think you can imagine how one would construct these 2 shorthand statements into a properly expressed prose response. Let me sum up the PST routine once again. So the number of marks indicates the number of PST sets. So I see 2 marks, I prepare 2 PSTs, 3 marks, 3 PSTs, just to get my structure going. And then I can write in the easiest statements first. So I take a look at a question, and there's some statements I can lift directly off. Typically, it is the first since statement and the final therefore statement. There are other occasions where we can lift even the principle. So for instance, some questions might tell you, using Newton's laws of motion, please proceed to explain. And so since you're already tasked to use a certain principle, you can also lift that up and put that into your explanation. And then, of course, you fill up the rest. So after you have written the first since and final therefore, proceeding and filling up the rest of the statements is not really a set way to do it. It tends to be rather organic, so it depends on you and how you feel doing the question. I'm going to demonstrate one more time how you might use this routine inside an exam question. So I've got the routine on the left-hand side, and I'm going to use this question. A car A travels at a higher constant speed than car B. With a suitable explanation, compare the driving forces of car A and car B. Now it's a 2-mark question, and so I'm going to proceed with putting in my PST. So I've got the PST there, and I also like to use subscripts P1, S1, T1, P2, S2, T2 to structure myself, and also, it's good for discussion as if I'm doing this in class or with anyone else. So I'm done with the first step. Number of marks indicates the number of PST sets. The second thing is I'm going to write in the easier statement, the first since and the final therefore. So I'll proceed with that. And once again, I'm writing in shorthand because this is a quick thinking routine to support the full prose I'm about to write later. I say velocity of A is greater than the velocity of B, or the speed of A is greater than the speed of B. And notice I can write the final therefore statement. The driving force, Fd, of car A, so those are my subscripts, is greater than, equals to, or less than the driving force of car B. So I'm using the subscripts to just speed up my writing a little bit, make it a bit more compressed. And if you notice from the question, I am still not decided whether the driving force of A is greater than, equal to, or less than the driving force of B. So I can leave it still pending. But it's still good to write down because it helps me focus my explanation and direct me along the correct direction. So I'm going to start, and I've filled in my first principle. Based on the fact that car A is driving at a greater speed than car B, and I'm going to employ the principle air resistance increases when velocity increases or when speed increases. So a faster moving object experiences greater air resistance. And because of that, I can conclude that the air resistance experienced by A, the force of the air, is greater than the force of the air resistance experienced by B. I hope you're doing okay with the shorthand that I'm using. Now remember that T1 can become S2 if I'm using a causal chain. So I can just pop that right in. The force of air resistance experienced by A is greater than the force of air resistance experienced by B. And now you can see I'm almost done. I want to connect S2 to T2. So what principle could allow me to relate individual forces to each other? And if I think about it for a little bit, I think I can use Newton's first law of motion. I combine Newton's first law of motion and the fact that car A and car B are in equilibrium, so they experience zero net force, to say that the air resistance of A must be equal to the driving force of A. So I can therefore conclude that the driving force of A must be greater than the driving force of B, and I can make my decision and cancel off the other two. Finally, in terms of marking points, following the similar chain of reasoning that I had previously, principles tend to not be marked. I am not going to be marked for S1, since 1, because that's a repetition of the question. And T1 and S2 are repetitions of each other, so only either one gets the mark. Therefore, the marking points here would likely be T1 and T2. So I'm going to take all this information and we're going to put it together into a prose response. And this is what I might write in the exam scenario. Since car A travels faster than car B, no marks there because it's a repetition of the question, car A experiences greater air resistance than car B. That would be my first therefore statement. Since both cars do not experience net force, which I have inferred from the fact that they are driving at constant speed, the driving force of car A must be greater than car B. And according to the underlines, I anticipate that those are the marking points and I'll get the full 2 marks. I'd like to end with some notes. Some principles are not part of what you need to memorize, such as the example we just did with regards to air resistance increasing with speed. If you go through your notes, sometimes you might detect some principles which are useful, although they are not required learning. Pay attention to marks. Determining the mark allocations takes experience and skill. Like I said, many of the things I said, especially the fact that 2 marks leads to 2 PSTs, tends to be a rule of thumb. I believe as you go along practicing this thinking routine, you'll become more proficient in determining where the marks allocation goes. Finally, although utilizing principles does not generally get you the mark in the question, but if you really are good with your principles and you have memorized them well, and you might even have the habit of writing them in full for your explanations, which I think is a fantastic habit, if you follow the vocabulary and language of your principles closely, I'm confident you are more likely to hit all the required keywords, and keywords will be less of an issue in terms of you losing marks. So I thank you for your attention in this video, and I hope this thinking routine will be a huge asset to you in your journey through physics.